So, hello everybody. First of all, I want to ask, and you can give me a feedback in the chat. You, if I'm right, haven't participated last week, or has everybody participated? No. Okay. So then, let me give a short introduction what we are doing and especially what the exam is about in this course. So this course is called, in brackets, Advanced Statistics, since I made the experience that if I would directly start with, so to speak, advanced statistics, time series analysis, hypothesis testing, and so on, then I would be alone in this course. And therefore, I will start with you with a short introduction of the main concepts in statistics, and hopefully you remember this from your statistics course. And quite often I will do it with you together using a direct example, and that we are start then to manipulate the data within Excel. And therefore I would recommend that you also open at home an Excel file, because then we can do all this together. And in general, I will go with you through the content in this course, but on the other hand, of course, I recommend some statistics books, and in general, you can use almost every standard statistic book you can find. And also what I recommend is that you find many sources in the internet, ebooks, and also online free material. Here is one thing: Open Intro Statistics. So is it opening? Hopefully. There it is. There you find many materials if you also want to go further. And what else I would recommend is, I also mentioned this in other courses of mine, MIT OCV. This is the open courseware of the Massachusetts Institute of Technology. Since now almost 15-20 years, they present their lectures, and maybe this is one of the best universities in the world online. And there, of course, you have also statistics courses. Let's see. Statistics. There you might find many statistic courses. And I also would recommend, if you have other lectures, not only my lectures, you can compare these lectures with maybe lectures from one of the best universities in the world. So actually it is no problem to study online at the MIT. The only thing is that you cannot do the exams there, because for the exam then you have to pay roughly $50,000 per semester. Anyway, so and especially I would recommend the last book here, A Guide to Modern Econometrics. This is something in between an student edition of a statistic books, but also a statistic book for every applicant who wants to do any time series. Yeah, so I will go through, as I already mentioned, with a short revision, ending with the so-called central limit theorem. Do you know what the central limit theorem in statistics is? Hopefully you have heard this. Since we are not many students, you can also use your microphone. What is the central limit theorem in statistics? Or you say that you never heard of it. Where is my loudspeaker working? Let me see. Oops. Has anybody said something? Just try it. Test it. So it's working. Nobody is saying anything? Or is everybody having a coffee? Actually, I need some feedback from you. And this, since we are not that many students here, this will be some kind of interactive lecture, because otherwise I could just record some videos and then you look at the videos. Are you still there? Never heard of the central limit theorem. Okay, then roughly this is what statistics is about, because what we are doing is we are collecting some data and then you want to get out something out of the data. Well, for this, then we are calculating what I have written here for the short revision. Means of this data, dispersion measures like variance, standard deviation, and so on. But all this is only descriptive analysis. Then you can only say, well, the average of my answers is that I will buy a product for on average €3 or something like this. Then you cannot say anything about the reasons because of your because the average is €3. And then when you asking for causality, then you have to make assumptions about the distribution of your data. Well, and very often we use the assumption that we assume that our data is distributed due to the normal distribution. Have you ever heard of the normal distribution? Yes, and I hope that you have in mind how the distribution looks like. If you take the density function, then it looks like this Gaussian curve here. Well, and have you talked about this distribution, about the reasons why it is called normal? Why do we call the normal distribution normal? Well, there has to be some reason. Well, the cause why we call this a normal distribution is because we very, very often find this distribution in nature. But we are in social sciences. Well, and the problem in social sciences is that we can just say, well, I'm not acting like a scientific law. I can just say no. This is in general a problem in economics. We derive under these assumptions. Think of the utility theory in microeconomics, where you are deriving utility functions, setting them to 0, and then there is coming out a demand function and something like this. But of course, preferences are free, and I can just say, well, you can assume that more is every time better. But for myself, I can just say, well, no, for me, it's not. So, and for this, it is not that easy to say just, well, because we find in physics, in chemistry, in biology very, very often this normal distribution. So let's use this distribution also in social sciences. Because when we individually are acting, then we always can act in a different way. But then this very, very, very powerful theorem steps in, the central limit theorem. And the central limit theorem states that if the number of your data is large enough that then the average of your collected data out of a data set of 100 or 1,000, 10,000, then the distribution of this average tends to the normal distribution. And this is a mathematical theorem what we can show, that if the number tends to infinity, so to speak, if we ask many, many people, then we can say that although we don't know how our xi are distributed, so here distribution is unknown. Remember, we can act as we want. Although this distribution is unknown, we know that if we ask enough people, if the number of our data sets is large enough, then the average of our data set tends to the normal distribution. Well, but of course, statistics is not that easy that, so to speak, we can look only at the normal distribution. But the normal distribution is quite often a very good choice. But now we are in the field of economics. And in the field of economics, we deal very often with prices. And one central market we are looking at is the stock market. And there, every day, very much data is generated. In every second, you can look at the price of some stock. Even, and this is called high frequency trading, even in every nanosecond, there you can find a stock price. Well, and with this data, then you can look, is it true that if I take many, many data, because still here we will never reach infinity, where we can say that we meet the normal distribution. And in financial markets, there is something what we find, that the assumption that stock prices, or the log to be precise of stock prices, is normally distributed is a quite good assumption. But we find that the statistical mass of these very rare results, that the statistical mass of very rare results of the normal distribution is too low compared what our historical data in financial markets say, what we see, how often very rare results happen. And what are very rare results? For example, a crisis. So a crisis like the dot-com crisis, like the financial crisis, like Corona crisis, like the European debt crisis, these crises happen much more often than compared to our expectation if we would say that our data is normally distributed. Well, and so to speak, this is what I want from you, because I think you have already seen this in the Moodle course, that as an exam you should write a term paper and especially you should have a look in your term papers on statistical methods in general. This is, for example, these two. And then there are other topics where you should analyze a method which is comparing the normal distribution with the actual distribution of your data set. So these are tests where you can test, is the assumption that the normal distribution, that my data is normally distributed, that this is a good or a bad assumption. And this is especially the Kolmogorov, Shapiro-Wilk, Jacques-Berrat, and then in the end, here, these three, this is time series analysis. Have you already heard something about ordinary least squares? Well, I did it in my courses, but in statistics. So what is ordinary least squares? This looks like this. If you have some data, so to speak, maybe you can collect data on that you ask, well, what is the dependence between revenue and costs in my company? And then you collect every quarter your revenue and your cost in your company, and then you get a data set. Well, and maybe you find a data set like I have shown it to you, like this here, that the higher the costs, the higher is the revenue, maybe. Well, in order to forecast, then where will be my revenue if I increase costs, so to speak, then you pose the question, if I hire new people for my company, this in general would mean that I will have higher costs and hopefully my revenue also increases. And maybe I can say this hypothesis I pose because I know from my historical data in the past that I have a positive dependence between revenue and costs. And for this, in general, one tries to fit, so to speak, through my data points, some function which should measure this dependence between revenue and costs in a good way. And one method is the so-called ordinary least squares method. And this means what would be the, so to speak, best linear line going through my data points. And the measure which I use is that I say, well, I want to minimize using this linear line the sum of all squared distances of my data points with respect to this linear line. So sum of these squared distances should be minimized. And this is called ordinary least squared method. Have anybody done something like this in statistics? Well, this is maybe one of the most central methods which you are using in statistics in order to do time series analysis. And for this, especially the last three topics here, these are about time series analysis. So all these topics are more or less standard topics. Well, they are not that easy from a theoretical standpoint. And so what I want from you is that you are really deeply dealing with these topics and that you try to understand the theory behind these methods. Well, it is not about that you have to go very deep in the mathematics behind it, but I want that you understand these methods. And why do I think that understanding these methods is very, very important? Well, if we go back 15 years, then there we had the financial crisis. And one of the main reasons, in my opinion, that the financial crisis has happened is that many people in the financial institutions didn't know anything about statistics. Because what have we done in the beginning of the 2000s, of the new millennium? We aggregated many financial products together. And then the idea behind this was, well, we have many different financial products. Of course, I know every single financial product is bearing some specific risk. And then in general, there was the hope that aggregating these products with the different risks, this means, well, I'm diversifying my investment. And about this, I think you also have heard in your business administration courses. That in general, it is a good idea to diversify your strategies in your company. not betting only on one horse. Because if this horse is losing in the competition, then you will lose all your money. Well, the idea is quite okay, but then if you do not know anything about statistics, then maybe you have a problem that somehow these risks of your different investments are correlated. That they, like I've shown it here, that these risks somehow depend on each other. And that there is the possibility also you are diversifying your investment, that in the end your portfolio has not a lower risk but a higher risk. Well, and actually this was then the outcome in 2008-2009, that almost all large financial institutions, insurance companies, largest banks in the world, they just had a look at their portfolios and that they have had to admit, oh shit, I have to depreciate many, many billions of US dollars and euros because these portfolios bear a much higher risk than I have expected when I invested in all these products. And therefore, also, if you are later on are working in a medium company and then you are making some survey and you want to get out information from your survey, then it is not just feeding in your data in some statistic program, pressing enter, and then you are happy and say, well, have there some numbers out of my statistic program. You definitely have to understand the numbers. And somehow, hopefully, this course is about understanding statistics. And therefore, you should choose one of these topics and writing a nice little term paper, not too long, about 15 pages until the end of April. And within these lectures, I will do with you many, many examples doing statistics and do especially hypothesis testing. This means we want to deal with causality. Okay, and next week we will then assign the topics, so please then enter next week the lecture. And in May we will find then some date where you should then roughly 10-20 minutes or something like this present your term papers. So, any questions to the formal part of this lecture? No? Okay, then we have some time left. So we will start with our short revision. Means and median. So hopefully you know what is an arithmetic mean, what is a geometric mean, and what is the median of a distribution. And for this, we will start with a little example and we will generate our data by our own. So what we should do is to generate a data set of 15 male students with a length around 175 centimeters and the maximum deviation of 25 centimeters. So our data should somehow lie within the interval 150 and 200. And for this, we want to use also the mathematical formulas in Excel. And there you have a formula which is called Zufallszahl. Well, what you also can do is that you change the language of your program. Then you have the English version. There you have, of course, also all these formulas in English. I will do this in German because always changing the language in a statistical program is not that easy because then also all ways the data format is changing, and maybe you know that in UK and in the United States you write digit numbers not with a comma like we are doing this in Central Europe, but you are writing this with a dot. And well, this means that if you are using in Excel a spreadsheet from the United States, this is not directly compatible to a spreadsheet which uses German or French as a language. And in order to get not these problems, I will still use here the German formulas. So what is this function doing? This function gives you just a random number between 1 and 0. So this then means if we subtract from this number 0.5, we obtain a number between minus 0.5 and plus 0.5. So, and now we want to have a maximum deviation around 175 of 25 centimeters. This means if we multiply this random function with 50, we obtain some number between minus 25 and plus 25. And since our data should be distributed around 175, the last step is that we just have to add here 175 plus this random number in the interval minus 25 plus 25, and then we obtain a random number in the interval 150 to 200. So how many data points should we generate? This is 15. So then let's have a look. One more. And of course, we just copy this function down here, and what we get out is 15 data points within the interval of 150 to 200. One question: have you already used Excel within your studies? Yes, okay, this is great. Because this I really recommend that you should do it. If you are writing some term paper, some project, anything like this, where you have to deal with data, please directly choose all the software possibilities you have. And we have to admit, this product from Microsoft is maybe the most common in the world. So in the end, when you start working later on, then in general, you will deal with some Office package. And for this, it would be a very good choice that you learn how to use it before you start working. Well, I haven't done this, and then I had to learn all this by training on the job. This were many, many night shifts. So in general, we would say it's in centimeters. So let's cut this at the second digit. And what you see here is if I'm clicking in this and here and pressing now enter, then always the function is generating new numbers. And of course, now we want to calculate averages and so on from our data set. We do not want that always our data set is changing. And therefore, I take now these numbers. Oops. Copy this. And now choosing here that we want to have only the numbers and not the function behind it. So here you see already we have new data, but this is the old data which I have just generated for a second. So this is our length and from our male persons. So first thing I want to have is the arithmetic mean. Do I have it here? No. Then what should I do? Means and median. What is the arithmetic mean? What do I have to do then? 5 minutes. Arithmetic mean of a sample. I said this is an interactive lecture. This is maybe the most common measure of an average. What would you do if this is our class? The first guy has a length of 1 meter 76, the second 1 meter 89, and so on. If you ask what is the average length in this class, what would you do? Sum all values and divide by the number. Great. So, and can be done here by summing up all numbers and then dividing this number by the number of our data set, 15. And of course, within the program, we have the nice feature that we have also the function average, and this is then hopefully also 170, and let's see that this is the same. Here we have the same numbers. So arithmetic mean is x bar equals 1 over n sum xi I from 1 to n. What else do we have? We have something like a geometric mean. What is this? And have you an example where we use geometric means? Hopefully you have introduced in statistics different measures of a mean, different average measures. Because although this is the most common, it is not always a good choice to use. the geometric mean. So this is 1 over n, x1 plus x2 plus x3 plus and so on. Ever heard of the geometric mean? Have you entered some financial courses? Do you know what interest rates are? Interest rates are nothing else than the growth rate of your capital. And quite often when you want to make some investment decisions and you have different financial products, then you want to average different interest rates. And this you should not do with the arithmetic mean. This you should do with the geometric mean. What is the geometric mean? The geometric mean is the nth root of the product of your data points. So this is then x1 times x2 times x3 times and so on to the power of 1 over n. This we also can do, geometric mean. Geometric. So this is then product of all my numbers and then the nth root of this product. Or, of course, you have also the direct function, geometric mean of these numbers. And you see, they are quite close, but they are not the same. And the last one, the harmonic mean. Have you ever heard of this one? So this we will do then next week, but you can think of, I don't know where you are living. Maybe you are living in Oldenburg. And then you can think of, you have been driven today from Oldenburg to Wilhelmshaven. This is, I think, roughly 50 kilometers. And maybe this morning you were quite early on the street and you were alone and you had a different velocity of 100 kilometer per hour. And later on in the afternoon you are driving back and then you are not alone on the street. And since there are also many other cars, maybe your velocity is then only 50 kilometers per hour. Calculate the average velocity for the whole distance, Oldenburg, Wilhelmshaven and back, which is 100 kilometer. So hopefully you intuitively already know that the answer is not 75 kilometers per hour. So this is your homework for next week. And thank you very much for today.